This is Terms of Reference podcast number 146.
Even though now this exposes this huge flaw in objective thinking, that there are places you cannot get if you're trying to follow an objective. All of these treasures out there that you will not be able to get to if you make them your objective, you will only be able to get to them by not trying to.
This is Terms of Reference. I'm your host, Stephen Laddick. How obsessed are you with goal setting? I mean, seriously, if you've been living on planet Earth, you know that those invested in the science of achievement have done an incredible job of not only convincing, but actually getting us as a whole to adopt goal setting as a lifestyle. Even if you don't set goals, you know it's something you should be doing. And full disclosure, I'm not only a living, breathing product of this paradigm, but I'm also one of its loudest proponents, at least in my own mind. Goal setting has become something of an absolute in the design of products, services, and programs in the social sector as well. Just think of how many times you've designed theories of change, or conceptual or logical frameworks, or smart indicators. You know what I'm talking about here. The obsession with defining the results that we want to achieve with our work, and perhaps even more importantly, how we will measure our progress towards achieving them. Well, I could hold court on how to improve the way we design programs to achieve social goals for the next 4 days. Here's the thing. This show isn't about that. In fact, we're about to spend the next hour and change talking about how creating objective goals may be the exact wrong thing to do when trying to achieve something amazing. My guest, and truly the inspiration for this 146th episode of the Terms of Reference podcast, is Dr. Kenneth Stanley. He currently works for Uber Labs while on leave from the University of Central Florida, where he is an associate professor in the Department of Computer Science. Ken focuses on artificial intelligence and machine learning. I learned about Ken from ISG's director, Michael Klein, when he shared an article with me from the 538 blog titled "Stop Trying to Be Creative" that was written by Christy Ashwanden. I'll let you read that on your own, but suffice it to say that I was intrigued and had to know more and how it might apply to the business of helping others. And I think that's exactly what you'll get in this episode. The revelation in this podcast should ultimately blow your mind. We get started by talking about AI and Ken's pet project called PicBreeder, and how that led to his discovery that objectively determining what we want to achieve may be the best way to miss out on true awesomeness. I spoke with Ken in San Francisco. But hey, before we get started with the show, a quick word from our sponsor.
The Terms of Reference podcast is sponsored by International Solutions Group, helping to improve the social impact of governments, UN agencies, NGOs, and companies for more than 10 years. Visit ISG online at www.theisg.com. Hello,
Ken. Thank you so much for being on the Terms of Reference podcast today.
Thank you, Steve. Very glad to be here.
Ken, you are recently you're a traveler, like most people who are listening to this podcast right now. Where is it that we find you sitting today?
You will find me today in San Francisco, which is not usually where you would have found me a few weeks ago.
And the reason we wouldn't have found you there is because you are the associate professor at the University of Central Florida, where you look at artificial intelligence, machine learning, amongst many other things. But the reason why I asked you to come on the show today specifically was because you wrote a book called Why Greatness Cannot Be Planned. It's called The Myth, and the subtitle is The Myth of the Objective. I learned about this book on the 538 blog, and the blog post was called Stop Trying to Be Creative. So it was an intriguing blog post, these kinds of things. But what's most intriguing in that post is, the focus on your work and how you are basically saying, look, to get to a place where you want to be, or to get to a cool creative solution to something, don't try to plan your outcome. And that's all a great setup to what we want to talk about, because it connects to the international development and humanitarian aid world that we're obsessed with logical frameworks and outcomes and outputs. But let's start with sort of the foundation of your work. Artificial intelligence, machine learning. How does a guy like you get to write a book about objectives?
Right. So this is a really kind of unexpected development that I didn't set out to get into. I was originally just interested in, like you said, artificial intelligence and machine learning, and particularly the brain. And I was interested in the idea of modeling and simulating brain-like things inside of computers. And the technique, as you would call it in the field of machine learning, that interested me through much of my career was called neuroevolution, which means setting up a kind of Darwinian-like process in a computer that causes artificial brains to evolve in the computer. And right now, in the field of machine learning, artificial neural networks are very popular. So this may be somewhat familiar to people who've heard of things like deep learning today, that those are actually artificial neural networks. This is something I've been working in for a long time, but connected to the idea of evolution. And so that for many years I was doing without any kind of ambition about writing a book against having an objective. But eventually it does lead there.
Can you just give me a little, I've read the term deep learning a bunch of times. You have a Reddit out there, you've got a number of pieces out there. Can you juxtapose that against neuroevolution for me? Sort of for lack of a better term,
sure.
With a deeper explanation? Like, what's the difference?
Sure. Yeah. So historically, there has been interest in what's called artificial neural networks for decades. And the artificial neural network is just sort of another way of saying an artificial brain, like something that's sort of like how a brain is hooked up in your head. It has the word neuron or neural in it. And so what it means is that, like, inside of the computer program, there are these kind of simulated neurons that act a little bit like neurons in your head. I mean, nobody would claim that they're entirely accurate, but they're sort of inspired by them, and they're connected in some way. So, neurons are connected to each other. And so in an artificial neural network, you'll have these artificial connections that allow those artificial neurons to send signals to each other. And people have been interested for a long time in the idea that maybe you could hook up these artificial neurons in a way that's sort of analogous to the way that real neurons are hooked up in real brains, and then maybe they can do things a little bit like what brains actually do. And for many years, there were a succession of what people would call training algorithms, or ways to get a neural network, once you hooked it up, to get smarter. And that really means to learn. So basically, you'd be exposing it to tasks or problems or data, and it would learn from that data and get better at doing something. Like, for example, it might get better at recognizing handwriting. You could show it images of letters, and it might get better at recognizing what they are, the way a human also learns to read. And so people were developing these neural network training algorithms for a long time. Usually these algorithms are based on the idea of that when a neural network makes a mistake, an error signal is sent through the network that causes it to update in some way the weights of its connections, or basically the strength of its connections, in a way such that the error will be reduced in the future. And so it gets kind of smarter and smarter over time. And this is called, the technical term of it is stochastic gradient descent, or SGD for short. But one of the problems is that it's difficult to know how to hook up these neurons with each other. In other words, like, what is the configuration or the architecture of a brain, even if you're going to run this gradient descent over it, but what is the architecture that is the most supportive of the ability to learn intelligently and efficiently?
Let me just ask you real quick too, again, super novice question. These are software-driven neurons. Am I correct? Like, or they're clearly, these aren't wires that you're connecting together. These are software. So is this the code class that you're putting together? Or what exactly does it look like?
Right. Well, so all of this stuff is, when we talk about like an artificial neural network in a computer, we're ultimately talking about computer code. So somebody wrote a program, but inside of that program, it will have a description of what a neuron does. Or it defines a neuron. So it basically says, like, a neuron takes signals in, and then it does something to those signals, and then it outputs its own signal. And that's basically a program that basically describes how those things happen. And it tends to be a very simple program. I mean, neurons, at least as they're described in these artificial neural networks, tend to be very simple, small computational units. So, like, it might just sum up its input and then output some function of their sum or something like that. And it's really the complexity of what a brain does is emergent from the coordinated activity of many, many neurons connected to each other. So any one neuron is a very simple, uninteresting device, but the program also describes how these small units are connected to each other, which is why sometimes in the early days they called it connectionism. And so information flows over those connections. And by flow, I mean that the program actually simulates information moving from one neuron to another over the connection between them. And so it's basically a big simulation of neurons sending signals to each other the way that they might in a real brain. But see, the problem is that what we don't know, you can do that, just program a bunch of nodes that connect to each other and send signals. But what we don't know is how should they be connected such that they will do something intelligent? I mean, just connecting things to each other doesn't automatically make it intelligent. And that's where all of the sort of magic of training of a neural network comes in, is a way to have the computer figure out how those things should be connected up such that some kind of intelligent behavior emerges from it.
Can you give us a specific example from either your research or somebody else, of what would a typical training process look like, or I'm trying to find a way to not use the word objective, but you say, well, look, I want to put one of these neural networks together, and I want to train it to do something. Like
sure.
Like give me, what's a concrete example of something like that?
So typically, of course, these things were trained with an objective, so it's a very kind of appropriate thing to call it, and sometimes people will even call it an objective function. And so, that actually does somewhat connect into where eventually I get to the point where I start rejecting objectives. But conventionally, traditionally, it is with an objective. And so basically we would say, so as a specific concrete example I just mentioned, and this is one that you often see in like introductory neural network courses, is trying to learn to recognize handwriting. And so you might say your objective, neural network in this case, is to, as accurately as possible, identify the digit that corresponds to the particular image of a written digit that you're looking at right now. So we feed in written digits, images of written digits that, say, a human wrote on a piece of paper, and the output of the neural network is a number of 0 through 9. So basically, let's say we're just learning to recognize written digits. And so then what we can get is an error. Like if I show it a 3 that I wrote on a piece of paper, and it outputs the output corresponding to the number 7, well, that's wrong. And so it is not achieving its objective, and we would then record that as an error, and we would use the fact that it was wrong to change its internal structure in some way, or its weights, so that the next time it would be more likely to answer that particular one correctly. And if you expose it to enough examples like this, like you just keep on feeding it images of digits, it show it a 3 and a 7 and an 8, and many, many examples of each one, many, many thousands of examples of each one, slowly over time, it will gradually get better from all of the mistakes it's going to make early on. And it'll start making fewer and fewer mistakes because it's optimizing with respect to that objective function, which is to minimize the amount of errors it makes, until eventually it will be very, very good, above 95% accuracy these days, above 99% accuracy, and it will be almost as good as, say, a human reading digits off a page.
One of the things I love about these conversations is, just listening to you make that explanation just underscores the profundity of, the human brain and our existence, right? I mean, how many times in my 42 years have I seen the number 3, right? Billions and billions. And the neural pathway or the neural network that is my brain, it's what you're trying to replicate, you're trying to achieve. And so to say, you need billions and billions of examples in order to get it right, I'm pretty sure that I get the number 3 wrong quite often still. But anyway, so you're doing this work, and you stumble, as you just said, you kind of started to reject, the objective as the end game. I want you to take us to where, how you got into PicBreeder, which, I'll let you tell that story. But so how did that, I once just, I'm sort of putting this out there sort of randomly, but your story is so fantastic because it's the same story that I hear in our profession so often, where people, they'll show up one day and they'll say, I want to be a lawyer. And then, they'll go to law school and they say, oh God, I don't really want to be a lawyer. And then they look at politics, but it's that serendipitous route to get to this place where they suddenly start, they find themselves in this profession of helping others, right? So it's a very similar pathway, and I love to hear it. But so you're sitting there, you're doing AI, you're doing machine learning, and you start to reject this objective function. So why don't you take the story from there?
Okay, yeah. So let me just go back to that connection that I did, the distinction I didn't yet make between deep learning and neuroevolution, because that's kind of a little relevant. a lot of people have heard of deep learning today. It's all through the news. It's amazing how it's suddenly become like almost like a popular culture word.
Hey, H&R Block just had an advertisement on the Super Bowl about how IBM Watson is helping people with their taxes now. So it's as pop culture as you possibly can get now.
Right. Yeah. So in deep learning, which is basically an extension of an old-fashioned learning algorithm called backpropagation, which was popular in the 1980s. It learns sort of the way I described, where like an error will be computed at the output of the neural network, and then we'll use that to adjust the network to reduce the error. I was, for whatever reason, had a different interest in sort of how you can get a neural network. Like if you think about that, like it's sort of like that kind of process, sort of like what a human goes through when they're learning, maybe in school or something. Like they make mistakes, they get corrected, they improve. But I was interested in this kind of more meta level issue of how did the brain get there in the first place? Not how does it learn during its lifetime, but rather how did it evolve? And so presumably over the eons that precede us in our ancestry, the brains of our ancestors evolved to become increasingly complex and sophisticated until they were human-level brains. But, our ancestors go back through apes, and they go back even to flatworms, and they go back even to things that didn't have brains. And so there was this huge process that went on for millions of years that eventually ended up with a human-level brain. And so I was interested in whether a process like that, which is not what happens over your lifetime as you learn some tasks, but what happens over eons of evolution, could somehow be recapitulated in a computer. Like you could actually get brains to evolve through some kind of evolution-like process. And if that sounds like kind of hard to grasp, the way to think of it is really like breeding, and then it starts to be a little bit more grounded. Because like if you think about breeding, that's not a hard concept. Like I have some horses, and I want to get like a faster horse. So
yeah, you take 10 of these neural networks and you say, you kind of mash them together and say, hey, what comes of them or something like that? Or
yeah, so we would say here's 10 neural networks. Let's have them all try to do something, like some task. Like maybe let's have them all try to control a robot that's trying to get through a maze. So each one of the 10 will get a chance to control the robot. We'll just do them all sort of individually. We'll see what happens. And then what we can say is, well, some of them are worse and some of them are better. Just like if you had a bunch of horses, some are worse, some are better. There's some variation there. And we're just going to mate the ones that were better. So we're literally going to breed them like we would breed dogs or horses. And then they'll have baby brains, which are basically their offspring. And we'll put them through the same paces. So those ones will then do the same task. They'll attempt to drive this robot. And the ones that are better will again be allowed to have children. And those will be their offspring. And that's the next generation and so forth. And this is sometimes called an evolutionary algorithm. And so what I was interested in was evolutionary algorithms for evolving brains, which is what people started to call neuroevolution. And so it's a bit different from the conventional deep learning, which is more focused on one lifetime and learning over a lifetime. But if you think about it, it's sort of complementary in a way, because obviously nature encompasses both, like how the brains evolved and how the brains learn over their lifetime. And both together are what constitute basically life, or what's going on Earth. And so while the deep learning has really caught on sort of lifetime learning aspect, the neuroevolution sort of looms in the background as an important kind of missing ingredient to sort of how did the brains get there in the first place, that have the architecture, the sophisticated, complex architecture that ours have, which has, by the way, 100 trillion connections in the human brain.
Right.
So it's sort of amazing that this process that has no engineer, no guidance, would be able to construct some contraption of 100 trillion parts. And that's what I was trying to understand, is like, how could this happen? And can we make algorithms that can construct things like that automatically? Because if we could use them for all kinds of great stuff, not just for evolving a brain, but if we can just evolve multi-trillion part machines, we could have computers building stuff for us that we don't even know how to build ourselves. So this is what was inspiring me.
Hey guys, I just want to take a break for just a second. You've been listening for about 20 minutes now, and if you're excited about where this conversation is going and what you might learn down the road here a little bit, take a moment and share this episode with your friends or your colleagues on Facebook or Twitter. And if you never want to miss an episode, so you're always up to date here at the Terms of Reference podcast, click on subscribe. And what would be really super awesome if you're up to it. Go and give us an honest review on iTunes or Google Play or SoundCloud or Stitcher or something, wherever you're finding this, because it really does matter and it helps connect other people to the podcast so that they can also get in on the game of making it better. Now, back to the show with Ken. On the Reddit that you had, I think it was about a year ago, I was doing some research for this.
Yeah, that's right, yeah.
You said that when you're talking about deep learning or the big computation, big data trend, you said, and I'm just going to quote you here, you said, it's the exact opposite of the big computation, big data trend now in deep learning. It's tiny computation, but with really surprising results. Does that still resonate with you?
The tiny computation, but with surprising results, that was referring to what was that referring to? Could you just remind me?
It was referring to, the juxtaposing against deep learning and big, and it's basically big computation and big data trend. Maybe I've misquoted you there. I thought I thought that would be a good juxtaposition between deep learning and neuroevolution, but perhaps rather than looking at giant data sets and rather than looking at giant data sets and doing deep learning, you're saying give it a small task or a small result and see and do this breeding process that you're describing.
There is an angle like that here, where looking at the ability to really do impressive things with very few iterations, which is kind of the opposite of the spirit of what's really been driving deep learning, which is massive amounts of data. The discovery that neural networks are very good at proving if you have tons of data. But, neuroevolution can be data-driven as well. But we've also observed, like in PicReader, which you alluded to, this phenomenon of very interesting things happening with very little input. And so that is sort of the road that led to, so I don't want to suggest that that's the only way that neuroevolution can operate. It also can use big data. But this kind of small data thing did lead down this road that ended up with this book, which was this sort of anti-objective thing.
So tell us what, sort of, you give us the background story on PicBreeder so that we know that, and then we can figure out how you got to the book.
Okay, so this is a very serendipitous story, and it's really kind of circuitous in a way, like how one thing leads to another. So I'm sitting there trying to figure out how to evolve brains, and I created an algorithm for that, which is called NEAT, which stands for Neuroevolution of Augmenting Topologies. And basically, the idea of that algorithm was that it could evolve artificial neural networks or artificial brains that get more complex over time. That's what the word augmenting means in there, like they get augmented with more and more complexity. So I thought that it was kind of a cool idea for me because, in nature, presumably brains got more complex over time. So here's this algorithm which actually does that. And a lot of people also, I guess, appreciated that ability and were intrigued by it. And so people started experimenting with it on their own. And one of the things among many that people were doing with NEATs, and this is like more than 10 years ago, was the people had this idea that something I hadn't thought of, which was to ask the neural networks to draw a picture. And so the idea was that, a neural network can output anything you want it to output. I mean, it can output true or false. It can output a digit, like if you want to know, is this a 0 or a 1 or a 2? But it can also output something like a picture or even a song or whatever. And so some people were starting to say, well, let's evolve images that are generated by neural networks in this NEAT algorithm, the algorithm that I had recently introduced. And so, they created utilities. This is before PicBreeder. These were like hobbyists just playing around with NEAT, where inside of these utilities, like you could download them from the internet, and you could basically breed pictures sort of for fun. They were like toys. This is sometimes called genetic art. People have heard that term, or evolutionary art. But basically what it would do is it would show you like a bunch of images. Each image is generated by a different neural network evolved by NEAT, and you could choose as the user which one you wanted to be the parents of the next generation. And so usually like evolutionary algorithms just happen in the background. You don't actually interact with them. You kind of just wait, and then when they're done, and you see what pops out. But in this case, you were involved as a human being. You were able to say, this image is better than that image. I want to see what happens if this one has children. So then what happens is you point to the image, you'd literally be looking at it on the screen and say, make children, and the neural networks that drew that image would have a child or an offspring. And then you'd get to see what image that thing draws, and that would be somewhat related to the previous image. And I became really fascinated by these picture breeding programs. They were just because I noticed that I was able to breed things inside of them that I never thought that you would be able to breed so easily. Like I was able to, one thing early on that I read were spaceships, and they looked great. They were just amazingly detailed, and they had a cockpit and wings, and these are things being drawn by neural networks. And so I was just kind of fascinated with that. And I was talking about it a lot to my research group early on when I started as a professor in 2006. And I was like, this is just really remarkable. There's all kinds of implications of this. I still don't know exactly what they are, but it's just surprising that you can do this. And it's a small data thing because, I would only have to make like 50 different selection steps and I would get a spaceship, which, compared to like millions of iterations of modern algorithms.
I'm looking at some of the pictures that are on the 538 blog as well. I mean, there's a butterfly, there are a bunch of different faces, right. There's a candle, there's ridiculously complex, right? Anyway, so you were introducing this to your research group.
Yeah, so I was talking about this. This is before PicBreeder, which is where you've seen those images from. And there was a student who was attending my meetings. His name was Jimmy Secreton. And he said, hey, this would be a really cool online service. Like, if like people could just go on the web and like breed pictures and then upload them or have them saved to some big giant database where everybody else could see them. And I thought, yeah, that's an amazing idea. Like that really could be cool because we would be able to crowdsource the whole world. And what would happen would be that we would get to see human beings putting in their efforts converted into a kind of a survey of what's possible in this kind of world of neural network generated imagery. And I just thought it was too fascinating to pass up, and it led to PicBreeder. So basically my group resolved that we're going to actually build this thing. And we created this thing called PicBreeder, which is an online service, PicBreeder.org, where you can go on the web and you can see all these images that other people evolved. You can evolve your own from scratch, or you can evolve from someone else's image. Like if I evolved a face, you could say, I want to continue evolving that face. So people are allowed to evolve from their predecessors. And with this service, PicBreeder was for an academic project. It was pretty successful. We had hundreds of people come in and evolve thousands of pictures over several years. And so we had, at the end of that, a huge database of histories of how things had evolved and thousands of images that people had created or discovered in this process. And what you were referring to, those images that you saw there, those are from PicReader. And they were just, as you can see, they were remarkable. I mean, you would not expect, if you hadn't seen these kind of things before, that this would be the result of people breeding neural networks, that they look so realistic or recognizable, like actual objects like a butterfly or a car or a skull, or there's thousands of these, of course. And so this was just a very fascinating database and history of discovery that suddenly we had a possession of. Huge amounts of just over and over again, surprising, seemingly almost impossible discoveries, but happening on a consistent basis. And I started to think about what was causing this to happen. And actually, I had an experience myself where I evolved a car. I evolved actually the first car on the site myself, just playing around. And I noticed something which was really weird about that experience. I was very shocked that I got a car. I never thought I would get one. But more than that, I realized that I had not been trying to get a car. And that was an important part of the story. I actually started with an alien face, like someone else had evolved an alien face, and it was already on the site. And I started from that. And I had expected that I would just evolve more alien faces. Like when an alien face has babies, it's like a baby alien face and more alien faces. But the eyes of the alien face started going down just through mutations, and they started to look like wheels. And I realized I was getting a car. And I don't know if this experience had happened to someone else, if they would have taken it as such an important event. But for me, this was a very, very significant experience. It sounds like an obscure thing, but when I got that car, the thing that kept going through my head was, this is not how I was taught. Because I was taught that the way that you get things, and this is in the field of artificial intelligence and machine learning and engineering, and it's like the whole educational system in our whole scientific culture is like, or engineering culture, is, you basically set your objectives, and then you gauge your progress by your objectives. And if you're not moving towards your objectives, then you're making a mistake and you need to move in a different direction.
You basically are throwing to the wind Sigma 6, right? I mean, lack of a better term, but business planning, engineering, all of this is ties perfectly into international development and humanitarian aid, where it's like, if you're not moving in towards that objective, what are you doing?
Yeah, exactly. It ties into all that stuff, which is like a huge chunk of our culture. And many of our institutions run this way. And our educational system is modeled around that. And for me, I don't know why it resonated so much that this was violating that, but I just kept obsessing about this for a while. Like, what does this mean? Like, does it mean anything? Or is it just like one giant coincidence that this happened in this one case? And one of the things we did when I started thinking about this, what my group did, was we started to look at the history of other discoveries that were also pretty cool. Like, I mean, I discovered a car, but somebody had discovered a skull, and somebody had discovered a butterfly, and just innumerable interesting discoveries. And what we discovered was that in every single case, every interesting case that we had on there, it was the same story. None of them were the objective of the person who actually found them. And one of the ways that we know this is because we can see what the stepping stones were that they traversed to get there. And it's inconceivable when we look at those that they could have possibly been purposefully moving towards what they ultimately ended up at. Like, for example, I started with an alien face. There's no way that somebody who starts with an alien face is thinking, oh, finally I'm going to get a car. And we saw this over and over again as sort of a consistent phenomenon that basically just about none of the discoveries on the site, and there are many beautiful discoveries, were discovered as an objective. And that really, really drove it home for me, that there's something going on here which is important and very strange and is, kind of contrary to the whole way that we think discovery and creation and innovation work. And I started thinking about things like, if I was doing machine learning, like trying to train like a car to drive around a track, like typically what I would have is some kind of objective function which describes doing better, like getting farther around the track and farther around the track. And eventually it would go around the whole track and it'd be this big success. But then I thought there's another way of thinking about this, like not objective at all. Just think of it as, if I just said you have to keep on doing something new, like let's say you got this car and you've got to keep on doing new things. Like at first you might just drive the car into a wall, but then you can't drive it into that wall again because you have to do something new. So you might drive it into another wall, and then you drive it into another wall. Well, eventually you would have to stop crashing into the wall because you would have exhausted all the crashes that you could do against the wall, and then the car would be driving around the track. And I started thinking about, this is a very strange thing, because this is a totally different way of thinking about how you can learn to drive.
That's literally, if you think about teaching a teenager how to drive, that's literally the opposite of what you want to do, right? It's keep the car between the lines, not let's crash into everything so that we know those are all bad alternatives.
Yeah. I mean, this is definitely not recommended for actual trading session of the car. But, by the way, like in machine learning, we often do things in simulation, so we don't care about like things like crashing have no cost to us. So in a simulated car, we could do this for real. We could just
it's a beautiful. That's the beauty of the software environment, though, right? I mean, you can crash a car a billion times, and who cares?
Yeah. So this is very sort of a revelation, at least for me. It was like thinking about it this way. I realized that if you just keep pressing something to do something new, what I realized is it has to get sophisticated in some way. Like it can't stay simple, because eventually to do something new does require you to understand something about the world. Like you're never going to get out of the room that you're in unless you figure out how to go through the door. And so I sort of thought of PicBreeder as like this. Like PicBreeder is not an objective-driven process. It's not like many individuals there found things that were not their objective, but even in aggregate, like the whole community inside of there doesn't have any unified objective at all. It's not like if you polled everybody, they're all like, well, we're all trying to get this. They're all trying to get completely different things. They're not unified in any way. Most of them don't even communicate with each other. So what gives it the power that it has is the fact that it's basically a collector. So this is very different than an optimizer, because we love thinking in terms of optimization in our culture. But a collector is like a stepping stone collector, something that collects things that can lead to other things. And then if you say, well, where is it leading? That's the whole point. We don't know where it's leading. We no longer care where things are leading, because we're not trying to get anywhere in particular. We're just trying to create the potential to get to more and more places overall. And so this can be thought of as like a stepping stone collector, or sometimes they call it like a treasure hunting system. Like there's all these treasures. And the more treasures you find, the more treasures you can find, because the treasures are stepping stones to more treasures. And PicBreeder is this kind of treasure hunting system or stepping stone collector. And, we realized that my research group did that we can actually describe it more like a treasure hunting algorithm. And this is different than an optimization algorithm. I would characterize most of machine learning as sort of optimization algorithms. But a treasure hunting algorithm would be something that is intentionally just trying to collect new stuff just for the purpose of being able to collect more new stuff or discover more new stuff. And we created an algorithm basically that runs by itself. This is outside of PicReader, called novelty search, which was inspired by this insight. And the novelty search algorithm is an algorithm that will just try to get neural networks to keep on generating novel behaviors with no final objective in mind. And we showed that like certain tasks with novelty search, like for example, learning to control a robot that goes through a maze or evolving a maze navigating robot actually worked better than if we did the conventional thing of rewarding the robot for getting closer to the end of the maze. So this is very, very
is that essentially like the same kind of example of crashing the car into the wall? Because the robot would say it would exhaust every possibility that was incorrect faster than...
Yeah, it is a lot like that. Yeah, yeah, it's very like that. But see, the thing is, the objective version of this, like where we would say, and this is the way typically things would be done, and historically in the field, would be like we'd say, well, the closer you get to the end, the better you are. So that's your score. Well, this thing happens when you do that, which is called deception, which is that if there's a cul-de-sac, like there's a passageway in the maze where you're moving towards the goal and you're getting closer to it, but it's actually a dead end. Well, in the objective world, that actually looks good, because you're getting closer and you get rewarded for it. And so the thing about the novelty search, that it doesn't get deceived in that way. In some sense, it's immune to this kind of deception for the very reason that it's not trying to get anywhere. So it doesn't sort of get fascinated with dead ends and false paths that look like they're going in the right direction the way that objective searches do. Objective-driven searches tend to get obsessed with things that look like they're going well, even when they're moving towards a dead end. This is a technical term, which is a local optimum. Sometimes people in optimization have that term for it. But basically like a deceptive dead end. And novelty search doesn't care because it's not trying to get anywhere. So it's never measuring where it is against where it wants to be. So it can't be deceived this way. So it quickly tires of things that are no longer leading anywhere interesting. And so it much more rapidly sort of fills up the space of all these possibilities of where this robot could go, and much more quickly finds a robot that actually gets to the maze, which for many people was extremely counterintuitive. When they saw this result, and so many people could not believe it at first, but there's something flawed about this experiment, or maybe it doesn't apply in general or something, because it's just like almost hard to accept, because you have to remember everybody is taught in this tradition of like the way to get things done is to follow an objective gradient. And then you see this result that this thing that doesn't even know what it's trying to do is actually better than that. It was like antithetical to everything that people had been taught to believe or even believed. And so it took a while for people to start absorbing this.
Before you continue on, what's sort of resonating and going through my mind right now is, let me sort of, it's going to be a stark contrast here, but I'm thinking of a refugee camp, right? Or, a migrant camp where they would put internally displaced people who are, for lack of a better term, they don't have a place to go, right? And in these places, we see consistently, amazing entrepreneurial ventures, social connections that nobody would have predicted would have happened. Traditionally, the humanitarian world has given them supplies and other types of things, and inevitably, what happens is, we'll give them food and flour and fabric and this and that, and thinking, hey, make it, you can make a tent and clothes and these. And what they end up doing is, crafting a bicycle that has a motor on it, something that's completely. And so the point of where I'm going with this is two things. One, there may be some really cool real world examples of what you've discovered through a machine, right? Through machine learning, that may be applicable, and that'd be really interesting. But also, is what you're getting at is the question is more important than the objective. Like I'm trying to figure out how to say, because ultimately a robot going through a maze has an objective, but what you're asking the robot is, hey, don't get to the objective. You're saying, solve this question of how do I not run into walls? Do I have that correct?
The crux of it is, what is it that guides your decisions about what you do? Like, you may care about getting through the maze, but you may not guide your decisions by the question of whether you're getting through the maze. You may have other reasons for doing things in terms of what you actually decide to do. So, for example, you may say, I have no idea if this is going to get me through this maze, but I'm going to take this path simply because it's more interesting, because I haven't gone there before and I don't know what's there, but I have a hunch that it's leading somewhere new. And through that process of taking those paths, those unexpected paths where you have an instinct that something interesting is there, you may end up solving the maze. Or you may end up solving something else that you didn't really think you were going to do. You may have been interested in solving the maze your whole life, but find that actually you've now discovered some whole new kingdom that you didn't know existed that has nothing to do with solving the maze, but because of the fact that you took these novel paths. And so I think it's not just a matter of asking questions about something versus trying to solve it, but it's really even beyond that. It's just saying that if you have a willingness to explore and to follow your intuitions, that something is interesting as opposed to better. So we like to think this is better. Things are improving. We have a metric. We have an objective metric. Like we like to think about things that way. And prove to me that what you're doing is right. Show me the objective metric. But if you abandon that and say, is this just interesting? And don't try to justify it in terms of better or worse with respect to some metric, but just this is interesting. And have faith that because you're moving down the interesting path, it may actually lead to something interesting and something that you wouldn't have discovered otherwise. And yes, it may not be the solution to your problem, but in the end, that's not why you took that path. You took that path just because it was interesting. And so to some extent in our culture, I think we need room to be able to explore in this manner, because humans are very good at identifying what's interesting. And this is a very valuable resource, which is being negated by the fact that we do not allow people to do that institutionally. I mean, we only allow people to do things that they justify objectively, which means that all those stepping stones are being cut off and not followed. But I think I should just back up for just 1 second to connect to how did I get to there from these algorithms.
Sure. Mm-hmm.
I just wanted to connect that up. So that's like the last step in the story, is just still like even where I was describing to you this knowledge search algorithm and how it came from PicBreeder and how that came originally from neuroevolution algorithms. It still doesn't say, well, why would we write a general book against objectives for society? And really what happened was that when novelty search came out, I started getting invited to give talks at a lot of different places about the algorithm at first. And it was interesting to the machine learning community and the evolutionary computation community. What are the implications of this? But I started to notice that a lot of the questions I was getting at these talks were not about machine learning. And this is really unusual for like machine learning talks. Like, people don't usually talk about...
The geeks were like, wait, you're off topic. What are you going to do? You know,
Yeah, so I mean, people would be like, so what does this mean, in terms of like when I set objectives for my like research program or stuff like that? And like, does the same thing apply in my life, or is this just about algorithmic stuff? And the more I, got asked these kinds of questions, the more I started to integrate that kind of discussion into these talks, until eventually I got invited to talk to the Rhode Island School of Design. I gave a talk about these issues, and I was much more sort of willing to play with the like personal implication aspect of it, of like, you guys have objectives in your life, and what does this mean for that? And I sort of explored that a bit. And I was just amazed that like the response that I got was so emotional. I mean, I totally didn't realize that this resonated so much with people at like a psychological level until that event. And I had meetings, like they set up a meeting schedule for me to meet with some of these students from the school after. Mm-hmm. And they were like cathartic sessions, almost like therapy, where basically people would tell me, I've been doing this like my whole life, and I have not been able to explain like why I'm doing this. And everybody wants to know, like my parents want to know, my teachers want to know, but why would you be doing this thing? And this is particularly for artists maybe. And I just can't explain, but I just feel like I have to do it. Like, this is what I do. This is what I want to do. And for the first time, I realized that, like, after your talk, that I don't have to actually have an explanation. Like, what is my objective? And this is just following stepping stones for their own right. And this is what I basically am doing and have been doing. I just didn't realize it. And the talk that I gave kind of justifies taking that route, because, it's all about how there are machine learning results to support that taking a position like that or an approach like that can actually lead to better results than trying to follow some kind of defined objective. And so this made a lot of these kids feel a lot better about what they were doing. And that was when I suddenly realized that this needs to be a book, because I realized that this is speaking to a very large audience. This is not just about machine learning. This is speaking to how people approach their lives and like everyday struggle, and how society is approaching many of its biggest problems, which are almost always objectively driven, even though now this exposes this huge flaw in objective thinking, that there are places you cannot get if you're trying to follow an objective. Actually, that's a caveat that I didn't really highlight there, but we also found that like you can't get a lot of the pictures in PicBreeder if you actually try to get them.
I was just going to say, yeah, so if you consciously want a butterfly, you can't get there.
Yeah, because it's deceptive. So like the things that lead to butterflies don't look like butterflies. Follow the path of butterflies, you won't get a butterfly. This is a real paradox, like a serious problem. It's a problem in the field of search, in machine learning, just searching for anything. And it was recognized. I mean, people know about local optimum and things like that, but just how pathological it is was not, I think, recognized. That is a very pathological problem. And there are all of these treasures out there that you will not be able to get to if you make them your objective. You will only be able to get to them by not trying to get to them, which is just like the most counterintuitive thing. And it sounds like almost like some kind of crazy thing that you'd find in a fortune cookie. Like to achieve our highest goals, we have to abandon them.
Just going to say you're making astrology legitimate suddenly. No.
Yeah, it sounds sort of like that. And so, but this is like supported by empirical science and scientific results, and this is not just like a philosophy that, sort of wishy-washy thing that I just came up with because I wanted to be contrarian or something. This is just something I'm concluding from a preponderance of results. And so, like, this is, I think, a really big reason for everybody to be very concerned because, like, we run our whole society based on this objective approach to the exclusion of all of these stepping stones that could lead you somewhere very important, which we will not follow because we are so obsessed with this just following the objective gradient of progress. So I thought, like, both at a personal level and at a social level, society level, that this message needs to get out, at least for a discussion. Like, let's have a discussion. Let's talk about this. It's not a topic that's really on the radar. This is not a big political issue. There's no anti-objective movement out there. So nobody's talking about this. And so really we decided to write the book to sort of get this issue out there so that at least there'd be some discussion of it, because it's like no one's even aware that there is an issue. And so that's why it exists. And certainly I think it will apply. And I guess we'll talk about it a bit, like to kind of social issues that are of interest to your audience.
Let's dive in right there, is that we work in a world where, we're trying to solve some of the world's biggest problems, right? Like, how do you make sure that people have enough food? How do you end poverty? How do we make sure that we have accessible healthcare to everyone? I know this is sort of just throwing these big problems on your plate right here in this conversation, but what would you counsel for an organization that up to this point, right? And let me give a little bit more background. Up to this point, a typical path for an organization, for a non-governmental organization or a UN agency or whatever, would be to go to a funder and say, hey, I have an idea for how to kickstart the economy in South Africa, or I have an idea for how to better serve the healthcare system in Uganda. Would you please give me funding for that? And the funding would, if they're, successful in that proposal process, the funding would then come to them, but it's tightly earmarked in that, they've had to say, okay, you're going to achieve A, B, C, and X, Y, Z, and those, by achieving those, you're going to ultimately contribute to some greater outcome over here. And then they would be bound by those rules. They would be bound by that. And they would have very little flexibility about what they could do in their program, regardless of whether or not they found out if it was working or not. Now, let me caveat that for people who are listening, especially the funders who are out there listening. We know that there is some movement in the funding world to provide this kinds of flexibility. But what would you counsel, given your research and given your discoveries about how a system like that should be structured?
Yeah, so, it's a very familiar problem to me because I face similar issues when I write proposals to get funding for scientific research. And the culture is similar in that, they're looking for your objective, for one thing, like what are you trying to accomplish? And then they're looking for metrics to tell whether you're moving in the right direction, and those would justify the funding. And my counsel is that this is a dangerous approach, which is limited in value. I wouldn't say that it is entirely doomed to failure. Some of the resources go to that kind of objective approach, because one thing that I think is important to acknowledge is that sometimes having an objective works. It's not that it never works, especially if your goals are relatively modest. It's quite rational to follow an objective when you're being modest.
Give me an example of modesty before you go deeper.
Okay, modesty, yeah. So like, okay, you're working at a software company and they want to upgrade their software from version 1 to version 2. This happens every day. There's nothing really, it's not like we're wondering, is this even possible? Like, are you going to be able to upgrade the software? It's like, of course it's possible. We just have to identify several features that we're going to improve, and we're just going to do that. That's totally reasonable. We can set that as an objective and follow it. When objectives become problematic is when you're really looking at the blue sky, or looking at things where we don't really know what the stepping stones are that we have to traverse to get to where we want to go. Like really, really hard problems. And that's very appropriate for what you're talking about, because I think you're talking about really, really hard problems. It's like we don't know what are the intermediate stepping stones between where we are today and the end of world hunger. Like, what are going to be the intermediate stepping stones? And so because we don't know that, the objective approach is really dangerous, because basically what it will want is to see that hunger is being reduced objectively over the process of some kind of proposed program. And we don't know that actually reducing hunger leads to ultimately universally reduced hunger, which is the paradox again. Like, if you assume that the way that you want things to be resembles the stepping stones that get you there, then of course you're going to assume that the stepping stones are all just sort of baby versions of getting to the final goal. But of course that's incredibly naive. I mean, the things that lead you to huge, earth-shattering, mind-blowing results don't necessarily resemble those results. They can be completely out of left field. And that's why we need to have the ability to explore in directions that are not objectively justified. We are exploring because they're interesting, because those are going to create those stepping stones that eventually might be the stepping stones that lead to that great breakthrough that you need. And of course, this creates a real problem for people's security, because I want to know, you got to show me that you're really going to get some results, right? You can't just go play around for 5 years. Show me something concrete. But we have to create some flexibility in the system to acknowledge this, because this is reality. I mean, we have evidence of this. The alien face that I saw that eventually led me to a car would never have happened if there had been a committee sitting there, which was basically deciding whether I should choose that alien face based on their interest in cars. I mean, they would have said, no way, how can you justify you're going to go choose an alien face? We're interested in cars here. The committees that are looking for consensus on objective measures are excluding those alien faces, definitively excluding those. You'll never go down those paths. But those are going to be the paths almost surely for all complex problems. I mean, that's why they're called complex. I mean, if you think about it, what is a hard problem? A hard problem is a problem where we don't know what the stepping stones are. If we knew what they were, then there wouldn't be a problem. We would just follow them. So they must, by definition, be things that are unexpected. They're going to be surprising things, and therefore they're going to defy the objective measure. For example, if you want everybody in the country to get 100 on their test, like we want the education system to improve and everybody to be brilliant, well, maybe the test scores are going to have to go down before they go up. I mean, there exist nonlinear landscapes that work like that. On an objective measurement scale, we will never allow ourselves to traverse those types of valleys, because we have to always be moving in some direction that we consider right. And so we need a much broader view of what it means to be a legitimate path for exploration than just it's steadily, monotonically improving in the direction that we want it to be. And I can give more concrete sort of example of how that could be. Because, I know that it sounds a little bit fuzzy still.
I'd
be convinced.
I'd love it. Love another more concrete example. I'm wondering if you could also wrap it around, let's just say that we're trying to make sure everybody in Ethiopia has enough to eat, but we're also making sure that everybody in Laos has enough to eat. Those are extraordinarily different systems, cultures, people. Yeah. Does the discovery methodology, the novelty methodology that you've been talking about, obviously that takes that into account as well, yes?
Yeah, so this is a very hard question. Just, obviously you don't want to imply that I'm going to solve the world's problems from the phone call, but I do think that I could provide some inspiration, I guess, for thinking about this differently, perhaps. So what I go back to when I think about questions like this is this stepping stone collector kind of metaphor, where we want systems where stepping stones are generated sort of consistently that could lead somewhere interesting. In this case, lead towards reductions of this kind of problem that we have. And so, but how do we create a stepping stone collecting system? Well, in some sense, an objectively driven system is the opposite of a stepping stone collector because it's very narrow in what it generates. Basically, you're always on one path, and it's a very narrow path, because if you deviate from that path, your objective score lowers, your metric is depleting, and therefore you're pushed back on the path again, because you can't go and deviate off the path. You have to be always reducing your metric. And so that kind of system is really contrary to what we would be setting up if we were doing stepping stone collecting. And we're not used to setting up stepping stone collectors. They make us uncomfortable, but also we just don't usually think about things that way. But to me, a stepping stone collector is basically a kind of a social network where the idea is to expose as many people to as many different approaches as possible without worrying so much about whether anybody is sort of the authority who's checking to see which approaches are best. That's sort of like what's going. So in PicBreeder, there's not like some panel of experts at the top that's sort of authorizing which directions people take. Anybody can come in and branch from any image they want and just continue on. And it's all completely organic. There's no kind of, oversight mechanism on the system as a whole. And this is why people are able to branch in all these different directions. And what's making it powerful is the fact that individuals who are involved in the system have been exposed to all the stepping stones. So they decide for themselves that, for example, this alien face is interesting and I want to continue from there. And I could be the only person who ever thought that was interesting, but for me it resonated. And I went down that path, and that's all we need is that one connection to be made and to see that that may lead somewhere fruitful. And so I think that, when we talk about something like, it's a different situation in Laos than in Ethiopia or something like that, all of those efforts that may occur in all of those different places, I think it was a very important thing that's clear is that they need to be aware of each other, and they need to be aware of both successes and failures in each other, and that there needs to be a social network where all of these different attempts and approaches are percolating through the social network so that these connections can be made, so that I can see that somebody tried this, and then I can think about whether that's interesting to me, regardless of whether it was objectively better than, approach B versus A or something like that. It's just that this approach resonates for me because I'm in a different context. I'm living in a different country. I'm working in a different country. And I actually realized that although this one was objectively worse in some comparison that was done, I suddenly see that it actually resonates with something that I'm familiar with in this country that's different. And therefore, I want to follow that. And we should then kind of expose to the full network all of these kinds of things that are going on and allow it to grow organically. And that way, things that look worse will get attempted. And that's one of the most important things here. You cannot expect everything to always be improving if you want to get to something revolutionary. You have to be willing to sometimes take a step back to take a step forward, at least on your objective metric. And so we need to have some degree of churn of crazy ideas, or at least not crazy, but ideas that are generated by experts but that do not have objective justification. I call it crazy because that's our culture, is to say if you don't have an objective justification, it's just a crazy idea. But the point is it's not crazy because if these are experts, these are people who've been working in the field, who have experience in this kind of stuff for many years, then their ideas are not going to be crazy, even if they're not objectively justifiable. It's just that they're influenced by intuition rather than objectivity. We're very uncomfortable with intuition and subjectivity. But the part of the problem is that is one of the ingredients that goes into stepping stone collecting, is that we don't necessarily know where we're going. So we are going on our intuition. And the point is people are really good at that. So we need to open up the ability to allow experts who have huge amounts of experience to exploit their intuitions.
Is there a way you teach that? I'm looking at sort of two practical things there. One is there counsel that you could give? Let's just say you're talking to a small NGO or even a big NGO, or maybe a UN agency or a government, and you would say, is there a way that you'd say, look, this is how you could practically inculcate this in your process? Is it as simple as saying, look, let people experiment and have mechanisms that are that look at those treasures that are being collected along the way and have a mechanism to say, hey, look, that one really worked. We like that one a lot. Let's codify that. Let's find it, let's define it and codify it and try to replicate that. Or what have we learned from the PicBreeder experience or other experiences from your research network of when you do stumble upon something great, how do you capture it and codify it? And say, great, let's go there.
So I've thought about this. This is really getting towards how real practical. How do you actually implement this? I thought about this to some extent in the context of education. So maybe I could just use that as an example.
That's perfect. Education is one of the world's greatest problems, my friend. So yes, please.
Okay. So maybe just because I think, you guys probably think about a lot of different social issues, and this may not sound directly related, but I think that because I've thought about it a lot, it might inspire other people to think of more unique ways of doing things, since I can give some details on it. In education, traditionally, at least in the U.S., we like to do things based on tests. And so we sort of think, how do we know that we're moving in the right direction in terms of getting everybody to be more educated? And so we use tests. That's why there's this kind of explosion of standardized testing going on to basically serve as a metric to show that you're making objective progress. And you can find written, literally by committees and politicians, things that say, if this particular approach doesn't improve test scores by 0.75% every year, then you won't get funding for the next year.
Funding is cut for the year. We've seen those. Yeah. Mm-hmm.
Yeah. So, you see that everywhere, and individual schools are subject to this, and whole states are subject to this. And so that's a very objective. This is the objective approach. And so what I want to suggest as an alternative is that the system really should be transformed into a treasure hunting system or stepping stone collecting system. And I can say concretely how that would be. But first, I just wanted to note that that system that as it currently exists is the epitome of an objective driven system. We're talking about a globally objective system, which is saying that the global objective is it should go up to basically optimal performance, which is 100%. And if we don't move in that direction, then we're doing something wrong. And this is, of course, extremely naive, because education must be one of the most complex problems that we face in our society. It's extremely complex. So how could we possibly believe that the structure of this search space is just a simple hill climbing problem where things just get better every year until you hit 100%? There's no way that actually works like that, which is why it never works. You know why? For decades, you keep on restarting, trying again, trying again. Because you're never going to just climb a hill like this to the top, and every step along the way is going to be going up, because it's going to be circuitous, because it's a complex problem. You have to go down and up and down and up, and this is obviously going to have to happen if there will ever be a revolution in education. So how can something like that actually be practically facilitated? And so my suggestion, I mean, I don't have like all the answers, but I'm just suggesting that to fashion the system as a stepping stone collector, a radical departure from that particular way that it works now. And what that would mean would be that, for example, instead of having like a universal way of grading how well everything is going, which is the standardized test, allow every teacher to create their own curriculum the way they see fit based on their experience. And then, immediately the alarm bells start going off. It's like, well, where's the oversight? Like, how do we know if people are doing what they should be doing? We need objectivity. Well, we can still have oversight in the system, because what the oversight will be is basically something like peer review. So at the end of the year, you'll collect all of the tests that you ran and the homework assignments that you gave and the progress of the students. You'll make a little portfolio, and you'll send in that portfolio will then be sent to, say, 5 peer reviewers, anonymous people throughout the country who you don't know randomly. And those people will then assess you and basically write down their thoughts on your approach and your success. And if you're absolutely terrible, we can give a standardized test or something. I mean, we can still go back to standardized tests if things are going awful. But barring that, we would have an assessment by your peers, and basically several peers, so we get a good average, so it should be fair. And what this would do is it would create a giant social network of innovation, because basically the reviewers are being exposed to the particular individual approach of one out of, thousands or millions of teachers, and get to see what that person did and why they did it and the rationales behind it. And then that individual would be exposed to the beliefs and views of the reviewers. And so percolating through this network would be ideas and people taking different approaches. And there's no overall objective thing saying this one is the best of the year or this is going the best. And there's not even something that says you have to be better than you were last year. But what's happening is that ideas are percolating through the system, and those are the stepping stones. And so people are being exposed to stepping stones, which is one of the most important aspects of a stepping stone collector, is that we need to have exposure to different ideas so that people can build off of the best ideas of their peers or their predecessors. And so this would be a radically different system, but I think it would lead to much, much more rapid and interesting improvements. And it would be also a lot easier on people because it wouldn't be all this standardized testing all the time. But then what I think is, okay, how does this connect to other things? I mean, this is in the sphere of education, but in the sphere of like proposals and like grants or something like that. I mean, you can imagine very different systems from this small panel of experts, which is a very narrow objective filter, which is sort of the way these things tend to work now. Like you send it into I guess you would have an NGO or something and say, here's what I want to do, and give me some money, and then there's a few people there who sit there and try to come to consensus. The stepping stone collector idea is not based on consensus. Like you can think about it in this educational scenario.
Well, let me even just throw a wrench in the works even there, right? Because let's just say you're an NGO or you're a social enterprise that wants to affect education, right? As you're saying.
Yeah.
They're going to apply to certain foundations who said, look, we support education and X and Y, right? These are our 3 things that our $1 trillion fund supports, right? And so I'm just listening to the way that you're describing how this sort of social learning, sort of networked approach to solving the problem, the stepping stone problem. And I'm seeing like a couple of different hurdles along the way because, okay, first of all, I'm the NGO and I've defined, I've narrowed the definition of what it is that I'm trying to do, right? So there's the first objective. Mm-hmm. Then I'm applying to the foundation that says I only fund things in these certain categories, right? And so there's the second filter. And then, there's a proposal and an acceptance committee, as you're saying. So there's a third or fourth filter through that. And what I find really interesting about this at this stage is that in order to affect education, maybe we need to turn on the plumbing, and there's plenty of these examples in the sector, right? Where we see much better educational outcomes for women when there are women's bathrooms. provided for them. You know what I mean? And so like applying for an education grant about how to do curriculum or how to affect the education system. No, what you needed to do was you needed to get money for water and sanitation to set up latrines and bathrooms for the girls, right? So you weren't going to get the educational outcome by looking at the problem through an objective, through the normal lens. But I'm not sure what you were saying before that. I sort of lost the train there.
Well, no, that's a great example. I mean, that might be the kind of thing where, like, how would that actually come about if we were living in this very objective kind of constrained paradigm? And so I think that the point I was going to go to from there was just that we can, one other way of thinking about where to invest. I mean, I think what these problems ultimately boil down to is where to invest, because there are limited resources. So we can't just let everybody do everything they want to do. So how can we intelligently allocate resources? Maybe instead of saying there's these narrow filters where things go through, where a few people look at lots of ideas and then choose the winners, we could have very sort of wide filters. So maybe thousands of people get to see all these ideas. And what you really need is just a connection where what you're proposing is the most world-changing thing for one person. Who cares if there's consensus? I mean, that's the PicBreeder way, right? Because, like, I look at all these images that other people evolved, and only I have to decide that this is the important image to me. No, there doesn't need to be any agreement with anyone else that this is a good image for me to branch from. It means something to me. And so I kind of think that it would be interesting to be able to expose ideas vastly or widely across a community, and then have a very, very small number of people have to commit, but really put skin in the game. And say, like, look, I want this to go forward. I'm one out of thousands of people who look at this, but for me, this is world-changing. And I'm willing to put some skin in the game. I'm not sure what that would be, but something, say, like, so that, like, you can't just vote for anyone. You're going to have to really sort of pony up if you're going to support somebody's proposal and do something to support it. But that would allow, like, basically us to make these very, very unique connections that will ultimately, inevitably, only happen between very narrow segments of the population. Like, it's not like you're ever going to get like thousands of people to agree on something, especially something radical. But if we can get this idea that this is everything I've ever wanted to see and it's extremely inspirational to me, then that's a connection that's been made in a PicBreeder spirit. There's been a stepping stone style where somebody wants to go off in that direction. Other people want to go in other directions. But that could be the kind of justification that we need, rather than this panel of so-called experts have come to consensus as usual on the usual status quo thing and so forth.
Ken, we've been talking for about an hour and a half now, and unfortunately I've got to bring our call to a close, but I feel like I could listen to you explain this fascinating, endeavor for another hour and a half without any, tiring at all. I really, really appreciate your time today, and thank you so much for being on the show.
Well, thank you very much. It's been great to have a chance to talk about this, especially with such important work that you guys do. So I really appreciated it.
You've been listening to the Terms of Reference podcast from 8preneur.com. Subscribe to us on iTunes.